Another topic is the sensor. You know the gyroscope is used to measure to create inertial monitoring units for the navigation of the platform, and is very, very effective tool, the photonics, because we can use the photonics in place of the very old mechanical gyroscope. The principle is exploited is the classical Sagnac effect, in which it's possible to realize a ring in which the light is traveling in both directions, and the relative rotation induce a phase shift of opposite sign in the two clockwise and counterclockwise paths. And measuring the difference, this phase difference, you know how much the platform has been moved in the space in comparison of the initial state. And the fiber optic is used to do that, and is a conventional product, the fiber optic gyroscope, and it is largely used in many of the platforms, including civil platforms. This is the position in which fiber optic gyroscopes are versus the other kind of technologies. You see that they are in the middle between the highly performant ring laser, but much more the performance are much better than the micromechanical system gyroscope. In the radar systems, the fiber optic is is coming to be a pervasive technology. The beamforming in many of the key function of the radar, like the digital analog to digital processing, or and then the analog to digital converting, or the antenna remoting. And this is a very crowded biography, but I would like to show you the two ways in which the photonics could ease an underpinning technology in radar in both the side, the analog processing of the signal, but also the digital processing of the signal. And probably you know that the key point is the analog to digital converting of the radar signal as the signal is received. And the photonics enable to do that without many of the intermediate processing needed to do that in the actual technologies, because enable you to work directly on the carrier and not you don't need to perform the down conversion to the IF frequency. We are also going to, this is something done, but we are going on, and we are now trying to introduce the photonic technology also in the computer of the system, enabling a very massive parallel processing and correlation between signals. But in the analog side of the microwave side, I would say, of the UGAR, you can see the example in which we are using photonics to generate the carrier. In radar system, it is a key factor, the phase noise purity of the signal used in the transmission phase, and doing that in exploiting photonics technology, we can get 10 dB better performance in comparison with the best of the analog frequency generator. We are also exploiting photonics in antenna remodeling, but also in the beamforming network. The beamforming network is a quite difficult thing to explain, but it is a very key factor in, especially when you want to reduce weight and size of the beamforming network in the backside of the radar of the antenna plane. This is a very this is the way in which we see the evolution of photonics in the future era. We are now in the step one, let me say, in which photonic support RF, analog RF, classical electronic RF system. But we are entering in the phase in which complex RF analog functions are performed using photonic technology, and we expect in 10 years to replace a significant part of the radar system using photonics, and then in the future, let me say 20 years, I don't know, most of the radar system with these functions will be supported by photons. These are examples of devices in which we are now in the final phase of industrialization. This is an example of analog to digital converter, and without entering into details, I want to stress the fact that this kind of device enables you to make the analog to digital conversion directly on the carrier. It means at 10, 20, 30 gigahertz, without the need to go down to less than a few megahertz and then to use classical electronics devices. This is the example of the frequency generator in which the cavity through which we realize the resonant effect is realized in very, very integrated form. The feature at the center show a so-called whispering gallery, in which a very small glass sphere, which diameter could be less than 1 millimeter, used to as a resonant cavity, in which the light is captured and stay there for the time needed to simulate kilometers of fiber in a very, very short, in very, very small dimension. This is an example of beamforming using fiber optic. And this is another subject, the optical interconnection. Optical interconnect is a key factor in the future electronics, in all kinds of electronics. You see in the top on the right, on the left, sorry, an example in which this is a feature taken from the Intel website. Intel is using photonics to enable the communication between devices in a single chip. This eliminate or reduce a lot problem of synchronism among the many different processors in a single chip. You know that the future, but also the nowadays chip in the computer are not single chip processor, but they are multi-core processor. They have in a single chip many computers connected through and in the plane of the single chip. In the future, Intel, Sun, and IBM have a roadmap in which the next generation processor will include up to 64 processors in a single chip. And the connection among these many processors is a key and terrible problem.
Yes,
okay.
yes.
Okay. So photonics eliminate all these problems because photons are fast and highly frequency. Okay, this is an example in which, a civil example in which the interconnection among the many parts of the airplane is performed in a civil pattern. The Airbus A380, the bus is realized, the communication bus is realized by fiber optic. You will see in the website this last view graph in which I included the future of photonics in terms of hybrid silicon photonics, in which on the surface of the silicon, electronics and photonics are merged together. There are also examples of photonics and the gap and plasmonics, and these are my conclusions. Photonics is a powerful, and I have no doubt about the power of this underpinning technology in avionics, but in many of the industrial applications. There are the possibility to exploit COTS, component of the shell, components from the communication market. This make easier the use of this technology because it reduces a lot of cost. And the impact in the backbone platform is very, very dramatic.
Thank you.